Alright, so we have reached the final part of your carbon compounds. Okay, so in these final two parts, you're going to learn about your fats and also your what you call rubbers. Okay, natural rubbers. Alright, so basically your fats are actually esters. Okay, so technically they can be divided into two lah. Alright, we call fat when it's in solid form. If it's in liquid form, we call it as oil. Alright, that's why we talk about human or animals. Alright, we call it as fats. Okay, when it's about fish or plants, we use the term oil. Alright, and since this is an ester, okay, meaning it's a combination between an alcohol and also a carboxylic acid. Alright, now in the case of fats, the carboxylic acids are called fatty acids. Okay, and the alcohol that is used for the what do you call for the production of your fats, okay, is glycerol. Okay, this is the name of the alcohol. Right, so your carboxylic acids, okay, or fatty acids, okay, is different than the one that you had learned previously because the carbon chain is actually more than 10. All right, so basically you only learn the naming until C10, meaning decanoic acid. All right, but in the case of fats, okay, the carboxylic acid here, the fat, what they call the carbon chain here is actually more than 10. Okay, so this is an example of the esterification reaction between the glycerol and also the fatty acid. Okay, so this is the glycerol. Okay, this one whole big thing is one molecule of glycerol, and inside one molecule of glycerol you have 3 hydroxyl groups. Okay, therefore if I want to conduct or to do the esterification reaction, I need to react with 3 fatty acids or 3 carboxylic acids. Okay, since I have 3 hydroxyl groups. Alright, so you need to remember for fats, okay, the esterification reaction is one molecule of glycerol, okay, react with 3 molecules of fatty acids. Alright, now this R here, okay, is actually referring to what they call carbon chain. Alright, so it can be, so remember since this one is fat, the carbon chain here starts from C10 onwards. Okay, so the R here can be C10 right up to C20 depending on what type of acid that you are using. Alright, and then this one whole big chunk of thing, alright, this is the molecule for fat. Okay, so this is a very big structure for fat. Alright, basically you're combining the glycerol, this is glycerol, with the fatty acids. Okay, so that is the reaction for fats. Okay, the esterification for fats. Now if you've learned in your biology, alright, triglycerides. Okay, I mentioned this previously. This is an example of fat, okay, that is in our body, triglyceride. Alright, so the importance, okay, why we need fats, okay. So this one you learn during your lower level science is that we need fats to provide energy. Okay, so basically one mole of fat will produce a certain amount of joules of energy that our body needs. Alright, and then if you know this thing, this is actually your membrane. Okay, this whole thing is an example of your membrane. Okay, in our body or in our cells, in our tissue, we have membranes in our body. Alright, this membranes allows what we call substance to go in and out of your tissues or your cells. Okay, so they allow substance to come in and out. Alright, so it's a very important barrier in our body. We need the membrane in our body to control the substance coming in and out of our cells. Alright, so the structure of the membrane is actually built from fats. Alright, so basically this one molecule, okay, is actually the fat here. Alright, basically you have the what they call or this is what we call a phospholipid lah. Alright, but Okay, don't go too technical, all right? Basically, your fat is used to build your membranes. Okay, this is one molecule of fat. So we have a lot, lots and lots in our body, all right? And then some vitamins need fat, okay? Hopefully you still remember the type of vitamins that can dissolve in fat, all right? So are they A, D, E, and K, all right? So these are the four vitamins that are soluble in fats. Okay, vitamin B and vitamin C, they are readily soluble in our body. Okay, as long as they have water, they can dissolve. But vitamin A, D, and A, D, E, and K, they can only be solubilized in fat. That's why we need fats in our body, all right, so that we can absorb these vitamins as well. Okay, and then, I'm very very certain that you have seen this before, omega 3, and then you see the word here DHA, okay, Enfagrow, your milk powder, all right? So all these are examples of fats, or what we call essential fatty acids, okay? So basically these are called essential fatty acids, all right? Okay, your omega 3, okay, your omega 3 is actually an example of your essential fatty acids. Alright, so an example of omega 3, okay, you can further give breakdown is DHA, which is you always see in your milk powder, or ALA, or sometimes you can even see what you call EPA. Okay, all these are actually short forms of the name of the fatty acids. Okay, this is what you call docosahexaenoic acid. Alright, so basically your DHA is actually important in our body because it helps in your brain development, especially for young kids. That's why baby milk powder, they have DHA, because this is a fatty acid that is what they call used to help in the development of your brain, okay, your brain cells, so on and so forth. All right, so omega fish oil, omega 3, this one also you can see in your eggs. All right, eggs or fish, they have a lot of omega 3. Okay, and this one, our body cannot synthesize omega 3, that's why we need to take it from a different source. Okay, we need to eat this. Okay, our body does not produce omega 3. All right, that's why we need to take it from the outside source, meaning your fish and your eggs. Okay, that is why we say that eating a lot of fish and eggs will give you a lot of the omega 3, which is essential in terms of your membrane, production of your membrane, and also brain development. Okay, so now, okay, you know the meaning of omega 3. It's basically your fatty acids. All right, okay. Next, we'll look into source. Okay, fats normally is found in animals. Okay, animal fats, chicken fats, goat fats, beef. Okay, whenever you eat your chicken, you will see the yellow thing sticking out, right? Yep, that is your fats. Okay, and then they are solids. Okay, remember, fats are solids. Okay, so butter, cheese, all right, is actually made from milk, right? So those are made from based on animal fats. Okay, plants are called oil because they are liquid. Okay, so we call them oil. All right, so vegetable oil, your peanut oil, olive oil, palm oil. Okay, these are examples of liquid fats. Okay, next is about the saturated and unsaturated fat. Okay, a lot of debate has been going on about the health effects of saturated and also unsaturated fats. All right, so we're going to look into the difference between these two things. Okay, so remember, your fats are made from glycerol and also fatty acids. Okay, so in the earlier chapter when we learned about alkane and alkene, you learn about saturated and unsaturated, right? So saturated meaning is single bond, okay, carbon-carbon single bond, whereas unsaturated is double bond. Okay, meaning that for unsaturated fat, okay, the carbon chain here, you will be able to see double bond in the carbo chain. All right, okay, saturated fats, okay, they contain single bond, okay, single carbon-carbon covalent bonds. All right, there's no double bond in the fatty acid here. Okay, that is what we call saturated fats. Okay, this is an example of a saturated fat. Okay, this is the name of the ester, meaning this molecule here. This is the name. All right, remember that alcohol. All right, our name we always change it into YL. Okay, so a little bit of revision. All right, methanol, we change it into methyl. Okay, ethanol, ethyl, propanol, propyl. Okay, we change everything to YL. Right, so the OL here is changed to YL. So this is called glycerol. And then your carboxylic acid, okay, we still follow the same thing. All right, if it's methanoic acid, it becomes methanoate. Okay, so if it's ethanoic acid, all right, it becomes ethanoate. Okay, so based on this name here, tristearate, tri meaning three because we are reacting with three fatty acids. Okay, stearate, okay, if it's stearate, meaning the name of the acid is stearic acid. Alright, this is the fatty acid. Okay, so remember how to change the names between the ester and also the alcohol and carboxylic acids. Alright, so one molecule of glycerol react with three molecules of stearic acid. Okay, that's why you get the name glycerol tristearate. Right, now in the case for unsaturated, okay, so they contain more than basically you have single and double. Alright, so for unsaturated fat molecules, meaning you have double bonds in the fatty acid, for example like this. Okay, so there's a mistake in the name here. This one should be glycerol trilinolate. Alright, so linolate meaning this is linoleic acid, so it's C18 if I'm not mistaken. Alright, 18 carbons. Okay, now if you look at the structure here, right, you'll be able to see double bonds in the carbon chain. Okay, so this is what we call an unsaturated fat. Alright, meaning you have double bonds in the what they call carboxylic acid, the fatty acid carbon chain here. Okay, right. So how do we classify fats and oils into saturated or unsaturated? Meaning, how do we say that this one is saturated and how do we classify them? Alright, so basically it depends on which one you have more. Okay, basically oil or fats, they are actually mixtures of both. Okay, meaning in any fats or any oils, you have two types of molecules inside. Okay, so whether we call it saturated or unsaturated is depending on which one you have more. Okay, so if let's say if I say this is an what they call a saturated fat, all right, meaning they have more saturated fat molecules, okay, compared to unsaturated. All right, for example, your animal fats. Okay, basically animal fat saturated. Okay, vegetable oil unsaturated. All right, so unsaturated. Okay, if you have more unsaturated, all right, you are considered as unsaturated fat if you have more unsaturated fats. So, wow, simply said, saturated, this one is animal fats. Okay, and then unsaturated is actually your vegetable oils or fish oils, for example. Alright, okay, so if we say vegetable oil is unsaturated, meaning inside vegetable oil the composition they have more unsaturated molecules compared to saturated. So maybe like palm oil, they have 51% of unsaturated. That's why palm oil is considered as an unsaturated fat. Alright, now in your alkene chapter, we also learn how to change from an alkene to alkene, right? Which is by hydrogenation, correct? Meaning if I have the double bond, I want to change it into a single bond, I add hydrogen in, which is hydrogenation. Okay, so in the case of fats, this is also the same thing as well. Alright, okay, so basically the double bonds here are easily oxidized. Okay, meaning that reactions can happen at the double bond. Okay, now when an oil oxidizes, it becomes rancid. Okay, if you know what's the meaning of rancid, meaning the smelly oil. Alright, meaning when your oil gets what they call when you store your oil too long, you get the smelly oil smell, right? That is the rancid. Okay, so an unsaturated fats, it can be converted through hydrogenation. Okay, remember we react with hydrogen. Okay, so technically margarine. Okay, margarine is made from unsaturated fats. Okay, your plant oil. Basically, you take your vegetable oil or your plant oil, and then you submit the plant oil into an hydrogenation process, meaning add hydrogen to the plant oil, and then it solidifies and becomes margarine. Okay, so basically you are changing from the liquid to fat, to solid. Okay, so what they call the discussion, or the what they call the argument is here. Okay, we have heard throughout the years many people are debating whether which one is more healthy, margarine or butter. All right, so technically people will say since margarine is made from unsaturated fat, it is actually more healthy. Okay, in general, unsaturated fats are more healthy compared to saturated fats. Okay, meaning vegetable oil, alright, is more healthy compared to animal fats. But this depends, alright. In the case of margarine, that is not really the case. Okay, so why? Later I'll just explain to you. But first, okay, what they call the health effects, alright. So you have LDL and HDL. So what is the meaning of LDL? Meaning LDL, the term stands for low density lipoprotein. Okay, this is the full name for LDL. Alright, if it's HDL, meaning it's high density lipoprotein. So, which is the good one, which is the bad one? Okay, so basically LDL is the not good one, the bad one, right? Because it causes what they call plaque. Okay, plaque meaning that they are going to stick at your artery wall. Alright, so when your veins or artery wall, okay, meaning if you have your artery wall, your blood vessel, alright, the LDL here, they are going to stick at your artery walls, alright, causing a disruption in your blood flow. Okay, that's why you get heart attacks. Okay, so technically all these are LDLs, alright, they causes plaque. Okay, plaque, alright, at your artery walls. Okay, whereas your HDL, they actually reduce, alright, deposits on the artery wall. So HDL is the good one, LDL is the bad one. Alright, so animal fats, okay, or saturated fats. Okay, remember, saturated fats have higher LDL cholesterol. Alright, whereas what they call vegetable oils, okay, right, vegetable oils or unsaturated fat, they have more HDL. Okay, so if you eat too much animal fats, okay, basically you are going to increase the level of LDL in your blood. Okay, and it's why we always say reduce the intake of animal fats. Okay, don't eat too much of fatty foods. Alright, because it's going to increase the level of the bad cholesterol. Okay, remember LDL is bad cholesterol, HDL is good cholesterol, the so-called good cholesterol. Alright, so which one should you eat more, saturated or unsaturated? Okay, so these are examples, all right, of diagrams that I've taken from the internet. Okay, so technically people will say you should take in more unsaturated fats, all right, meaning your vegetable oil, fish oil, you should take more. And then what they call saturated fat, you should reduce it. For example, your butter or your chicken, all right, so on and so forth. Okay, trans fat. If you see, there's a word here called trans fat. All right, basically trans fat is an artificial fat. Why we say it's artificial fat? Okay, if you remember our process here just now, when we change the unsaturated fat to saturated fat, what happens in this process is that you are going to produce the trans fat. Okay, that is why earlier on when people started manufacturing margarine, they say that it's better than butter because it's made from unsaturated fat. So technically you say, oh, since I'm made from unsaturated fat, it is safer and better. But as the years go on, people realize that during the process of changing the unsaturated to saturated, inside the margarine, they have a high amount of trans fat. This is very bad for your health. Okay, examples of food that has trans fat is the one that we love to eat every day. All your fried foods, your McDonald's, your KFC, whatever, okay, your French fries, okay, they contain a lot of trans fat. Okay, so for example, your chips, your potato chips, all right, when they fry the potato chips, okay, they contain a lot of trans fat. Okay, that is why we say you need to reduce the amount of, don't eat too much of your potato chips because of the trans fat. Okay, so as the years go by, people started to realize the existence of the trans fat. Hence, finally, people acknowledge that actually butter is more healthy compared to margarine. Okay, although butter is made from saturated fat, right, but compared to trans fat, this is actually much more safer. Okay, but doesn't mean that you can take butter a lot, right? Don't, because it's a saturated fat. Eat too much of butter, it can actually cause what they call it might okay, it might cause uh, changes in your cholesterol level. But this is for general knowledge, all right? There's no what they call direct research or indication that shows that actually saturated fat could increase the cholesterol level. There is no what they call 100% research that actually shows that if you eat more saturated, you get high cholesterol. Not necessarily. Okay, not throughout the findings of the scientists so far. All right. Okay, so that is just an extra knowledge for you guys. All right. So remember the what they call which one is unsaturated, which one is saturated, and which one is healthier for your body. Okay. All right. Palm oil. Okay, you need to know palm oil because Malaysia is rich in palm oil. All right. So basically, palm oil is from the fruit. Okay, and then if you see here, they contain 49% saturated fat and 51% unsaturated fat. Right. Since I have more unsaturated fat, that's why palm oil is considered as unsaturated fat. Okay, since they have more unsaturated fat molecules. Alright, that's why palm oil, we have a lot of uses. Okay, if palm oil you use in cooking, they say it's good for your health since this is an unsaturated fat. Alright, but if you change it into margarine and then taking too much of margarine, it might not be really good lah. Alright, but so you need to know the advantages of palm oil. Okay, they have a lot of vitamin E. Oops. Okay, vitamin E. Oh, right, vitamin E. Okay, antioxidants. Okay, you need a lot of antioxidants, right? And then they have beta carotene. Okay, inside beta carotene you have vitamin A. So vitamin A helps in a lot of what they call in your body. For example, your visions. All right, your visions you need vitamin A. Okay, for good eyesight and so on. All right, and then cholesterol free. Okay, meaning the amount of cholesterol in the palm oil is actually very, very, very low. So consuming it is actually much better compared to if you use different types of oil. Alright, so those are the advantages of palm oil. Okay, so that is the first part of your fats or what they call the carbon compounds. Alright, so that is it about fats. Okay, next we are going to go into your natural rubbers. right? So that is it for the application of your carbon compounds on fats. Okay, the next part we are going to go into the natural rubber, right? See you again.